So in the last class, we had discussed about the states of matter, which are solid, liquid, and gases. And we are going to discuss the next two states of matter today, which is BEC and plasma. The full form of BEC is already written, Bose-Einstein condensate. Then there were few terms which I asked everyone to revise and learn. First was the intermolecular spaces, or we can say that as interparticle spaces. So it can be said as interparticle spaces. Basically, what does it mean? It is the spaces present between the particles of the atom. Similarly, means what are the spaces which are present between any two particles of the states of matter. Similarly, interparticle space forces of attraction means the force of attraction that holds the molecules together, right? Then I had told about fluidity. It means the tendency to flow. So this was the structure I had drawn for solid liquid gases, and these properties we are going to re-revise because we have to study the comparison of the properties of states of matter, right? We left over here that we have to start with the comparison of properties of states of matter. So I will share a PDF in which we are going to study all the properties which we studied individually in the last class, right? Pranav and Rohit, keep your videos turned on. Pranav, keep your video turned on and keep it on only. Do not turn it off again and again. Okay, children. So today we are going to start with the comparison between solids, liquids, and gases. I'll be sharing this PDF. Whatever we have studied till today, you will be able to see here. Good evening, Yukta.
Good evening, ma'am.
You turned on. Okay, so we have to start with the comparison of solids, liquids, and gases. So the first property which we had studied was about the packing. Packing means how the molecules in the solid, liquid, and gases are packed. So the solids are very, very tightly packed, or they are closely packed. Then liquids are a little far apart, means less closely packed, and gases are very far apart, so they are free to move. Fine. So we had discussed this, that the particles of the solids are very closely packed, whereas liquid are less closely packed, and gases are very much free to move. Then was the force of attraction. This is the same which I was telling, that it is the interparticle force of attraction, means what kind of forces are present in solid. They are held by very, very strong forces. Liquid a little less, and gases there is almost negligible force of attraction. There is not much force of attraction. That is why the particles are very, very far apart from each other. Then if we talk about the shape, then shape is definite shape in the case of solid. In case of liquid, it is indefinite shape, and gases also the shape is not definite. Fine. What about volume? Only solids and liquids, both of them has definite, means the fixed volume, whereas gases have indefinite volume. All of this we had discussed in the last class also. Just it is mentioned in the form of table because sometimes you are asked to differentiate all three in this form only, so you should know in this form also. Then compressibility means when we apply the pressure, which has the tendency to change its shape. So if we talk about solid, definitely they cannot change their shape. That's why they are completely incompressible. Then what we talk about when we talk about liquid, they're almost incompressible. A slight bit we can compress. Whereas in case of gases, it is highly compressible. We had also seen the video in the last class, if you people remember. Yes, I made you all see the video of that syringe in which first we talk in the video they took chalk powder which represented solid. Then they took the water which was the liquid, and then the gas was taken which was the air. So in case of chalk we weren't able to compress it, whereas in case of liquid only a slight bit we could compress, whereas in case of gases we were able to compress to a large extent. Then we come to the particle motion.
I mean, compressibility for solids, there are exceptions. No?
There are exceptions for compressibility of solid. I am going to tell just after this table. Okay. In fact, not just about the compressibility, about the shape also we have one or two examples which we need to know, which are not exactly exceptions, but they are. But I will discuss after this table. Okay. Then comes the particle motion. So in case of solids, we know that the particles of the solid, they cannot move. They vibrate at their own position. Whereas liquid, we have seen that they can surely move. They have the tendency to move. And gases have the maximum freedom of movement. Means they are maximum, they can move from one place to another. Then rigidity and fluidity. Rigidity was the property in which on applying the pressure, if the solid changes shape or it doesn't changes the shape, or even if not the solid, if any substance changes the shape, then it is not rigid. If it doesn't changes the shape, then it is rigid. So the solids are rigid and fluidity was the tendency to flow. So liquids are not rigid, but they have fluidity. Gases, they have highest fluidity. Then we talk about energy. So the solids have the lowest energy. Liquids have, I'm sorry, liquid have a higher energy than the solids, and the gases have the most highest energy amongst the all. It has the maximum energy. Density, solids have the maximum density, liquids have lesser than solids, and gases have the lowest density. And last, diffusion, which I had told you all that the solids generally they don't diffuse into each other, they do not intermix with each other. Liquids, they do mix with each other, and gases, they also mix with each other. Clear? Any doubt in any of these properties? No? Okay, then I am going
No.
to tell you about the
Mom,
exception. Yes.
mom, can you explain diffusion?
So, we had studied about diffusion in the last to last class, I think so, in which we studied about the definition that the intermixing of particles is called diffusion. Means the mixing of one particle with another particle is called diffusion. It mainly depends on two factors. One was density, other was temperature. So density is inversely proportional, means more the denser liquid, lesser is the rate of diffusion. And temperature is directly proportional, means more the temperature, more is the rate of diffusion. Fine. Diffusion basically means mixing of the particles with each other. Clear
Yes,
now?
ma'am. Yes,
Okay.
ma'am.
Now let us see a few one or two exceptions related to. So these comparison of the states of matter, I will share that PDF. We will talk about a few exceptions. So children, we say that, acha, what do you say about a rubber band? Which state of matter is a rubber band?
Solid, ma'am.
Solid. Everyone agrees to this?
Yes, ma'am.
Yes. So rubber band is a solid, and do the solids have the property to change their shape? Do the solids change their shape? No, they don't. They have definite shape we studied just now. But rubber band being a solid also changes its shape, isn't it? If we stretch it, it changes its shape. So rubber band is a solid, but still it changes its shape. So how will you say that it is a solid? So what happens when it changes its shape? Only and only when we stretch it, when we apply some force. As soon as you release the force, the rubber band gets back to its normal shape. So this is an exception. It is conditional, that it happens only and only when it happens only when external force is applied. When external force is applied. Clear? As soon as the force is released, it regains its shape. So as soon as the force is released, it regains its shape. I hope this is clear. Harshit,
Yes,
you have
yeah,
joined. Is it clear what I have just explained?
yes, ma'am, it's clear.
What about you?
Yes, ma'am, it's clear.
Let's move to the next question or next exception, we can say. You are aware about the sugar crystals or the salt crystals. We will take the example of sugar crystals because they are a little bit bigger in size. We are able to observe them. So if I take a handful of sugar crystals or like a lot of sugar crystals, if I put them in a circular container. They will they will take the shape of the circular container. If I put them in the cylindrical container, it will take the shape of the cylindrical container. If I take a square box and put it in the square box, then it will take the shape of the square box. But whereas we say that the solids, they possess their own shape and they do not take the shape of the container, that's the property of the liquid, right? So how can we say that sugar is a solid? So sugar or salt crystals take the shape of take the shape of container but they are considered as liquid. Oh, sorry. They are not considered as liquids. Fine, children. This is the main question. So what is the main answer for this? The answer for this is that if we talk about just one crystal of sugar or salt, will it take the shape of the circular container, the rectangular or the cylindrical container or the square shape? No. The shape of the single crystal will remain what it is actually, right? So this taking the shape happens when the quantity is large, but when we talk about a single particle, the shape remains the same. So the answer for this is the shape of individual particle is the same always. There's no change in the shape. That is why no change in the shape. So we can't classify it as liquid. Clear, everyone? Any doubts still here? This as liquid. Akshara, keep your video turned on. Okay, there is one more last exception. What was it? Sponge. So if we talk about sponge, who was saying that there is an exception for this compressibility? Who said that?
Mummy only.
Yes, Sampath, you said na. So sponge is that exception. Sponge, being a solid, can be compressed, isn't it? But we just said that the solids are incompressible, right? So why we are able to compress the sponge? The reason for that is that the sponge gets compressed because of the presence of minute holes in itself, which has air trapped in it. When we apply pressure, the air comes out and the sponge gets compressed. It's actually the air which is getting compressed, means when we apply pressure, the air comes out and the sponge gets compressed, right? So sponge
Okay.
minute holes, means very tiny holes that has air trapped in between itself. So on applying pressure, the air comes out. On applying pressure, the air comes out. and the sponge gets compressed. Again, the same thing happens with this sponge as rubber band also, that it regains its shape as soon as we release the pressure. Sponge gets compressed, and on releasing pressure, it regains its shape. It regains its shape. Clear, everybody? Any doubts in any of the three exceptions which I have just spoken?
No, ma'am.
We should move further. Purujit, you have just joined the class.
Ma'am,
Yes, you've joined the class.
yes, ma'am. I had a simple problem. I have changed location, so the hotspot is like giving me problem.
So you are able to understand what I am telling. I am telling the exceptions for the properties which we studied in the last class. We studied a few properties of solids, liquids, and gases. So there are these three exceptions which I have just told, that rubber band is a solid, but still it can change its shape. Why? Because we apply the pressure or the force. Sugar and salt crystal take the shape of the container. So why do we consider them as solid? Because their individual particle doesn't change its shape. Lastly, sponge is a solid, but still it can be compressed because it has minute holes which has air trapped in it, and the air comes out of it as soon as we apply the pressure, and that's why it can be compressed. Is it clear to you?
Yes, ma'am.
And what about the others also? Any doubts in any of these three exceptions? If not, then we can move further. Right? I'm getting back to the PDF which we were seeing.
Ma'am, ma'am, I have another doubt. Like, what does vacuum consist of?
Vacuum doesn't
Means,
consist, all empty. That's why it is vacuum. When we take out air from any substance, that is where we create vacuum also. So vacuum doesn't contain anything. Fine. And also we don't consider vacuum as matter because it has neither mass nor it occupies any space. Fine, Harshit?
yes.
Children, we saw this activity in the last class in a video, so we can move further, right? Now let us come to, now this is very important to know all of this. And in fact, I'll tell you what all to know in all of this. This has a little extra content written. So I'll tell you and I'll guide you what to study. So we now come to the fourth state of matter, which we call as plasma. So what happens is when we talk about normal conditions, like normal under normal conditions, we have only three states of matter, which we have just studied: solid, liquid, and gas. But at very high temperature, there is a fourth state of matter which exists, which is known as plasma. Now, what is plasma? Plasma is a mixture of free electrons and ions. Now, where does these electrons and ions come? So what happens is when we take up some gas with very, very low density, then we start to heat at very high temperature. This gas breaks down and gets converted into free electrons and ions, which glow, because of which we are able to see many things glowing, which we are going to read about as the examples. Now this state of matter has super energetic and super excited particles, means the particles which make a plasma, they are very, 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 very high in energy. And this I have already told, that this state of matter has very low density. Now, the color of this glowing plasma, it depends on the nature of the gas. Like we will take the example. You must have all seen the fluorescent tubes, right? Yes or no? So,
Yes.
for example, in the fluorescent tube, there is helium gas, whereas when we see the neon sign bulbs, it has neon gas. When electricity is passed, the gas, they gets ionized, means they convert into ions, and we are able to see the glowing plasma. Clear, everyone? And one very important example is the sun and the stars. They glow due to the presence of plasma in them. Fine. Now I will stop teaching because I think your videos are turned off. I'll also turn off my video. and everyone will sit like this only. You hear me, I hear you. That's all. Keep your videos turned on, everyone. I will not repeat again.
Ma'am, one thing is again when plasma gets formed.
Yes, I can. I will. Rohit, you also keep your video turned on. I'll write here so that you are able to understand even more better. Fine. So plasma is basically the fourth state of matter this is the first thing you all need to know. What does it consist of? It consists of free electrons and ions. Now, where does these free electrons and ions come? So when we heat the gas, for example, we are taking only a few gases show the nature of plasma. So when we heat the gas at very high temperature, when we heat the gas at very high temperature, then these gases breaks down, leading to the formation of ions and free electrons are formed. Now the mixture of these ions and free electrons, it is known as plasma. And plasma can be seen in the stars and the sun.
Ma'am, if the normal air, if
Sorry,
we take
Samrit,
normal,
can you come again? Your voice is not audible to me properly.
okay. Ma'am, if we take normal air and follow this process, would plasma be present in it?
You're saying if it is normal air, then
Ma'am, if we take normal air and do the process of heating, then can we observe plasma?
okay, you're saying if we take the normal air and we heat it to very high temperature and if we can observe the process of plasma or not. So beta, one important thing, air consists of many gases, you are all aware about this, but here specifically only a few gases like neon, helium, they are able to show the process of the formation of plasma. So you cannot take the air because air is consisting of many other gases also, but only few gases like neon, helium, hydrogen, they show the process, means they break down to form the free ions and the electrons, and only then we observe the plasma. I hope the fifth state of matter is clear, fourth state of matter is clear to all. Now let us come to the fifth one. Just a second. Okay, children. Now let us come to the fifth state of matter. Again, I will tell you what all to study. It has in this PDF you have a lot of things, but you don't need to study so much because from these states of matter, very basic question come in the paper, not so much, but you should know some extra knowledge. I will be giving you from this PDF. So next is the fifth state of matter. Now, okay, I just said about the plasma, about something about the temperature. Tell me if the temperature was high or low.
I'm
Very
high.
right? Whereas this fifth state of matter has very low temperature, very low temperature, almost equal to 0 Kelvin. And this state of matter was known as Bose-Einstein condensate. And in 1920, there was one Indian physicist, Satyendra Nath Bose, who had done some calculations to about this fifth state of matter. According to the calculations, what happened was the Albert Einstein, he predicted the new state which was known as Bose-Einstein condensate. Now what happens in the state of matter is that the entire matter, it behaves as a single component, like one component or one atom. Why? Because the kinetic energy of the particles becomes so low that they are hardly able to move. So they behave as just one particle or they behave as just one atom. So this state of matter was also known as gaseous superfluid, and The first such condensate was observed by cooling. There is an element rubidium, which is written here. So when the rubidium was cooled to ultra low temperature, then we observed that it showed the presence of Bose-Einstein condensate. The large fraction of the atoms, they collapsed and they produced a superfluid. Fine. They all started to behave as one molecule, or you may say one atom. So now what all you need to study in this Bose-Einstein condensate, that I'm going to write for you. Like in the plasma, I have written in the very same manner I'm writing for. I'm writing for what? Bose-Einstein condensate. So I'll give you one more example apart from rubidium so that you should know two examples. So Bose-Einstein condensate. So first thing which you need to know is that it's the fifth state of matter. Fine, children. Then second thing, at which temperature it is formed? It is formed at
Very low temperature.
low temperature, almost equal to 0 Kelvin, equal to 0 Kelvin. And who all found it? So there were two scientists, Satyendra Nath Bose, because of which this name is given, and Albert Einstein discovered this state of matter. Just a second. Discovered fifth state of matter. And last, maybe second last thing which you need to know, that this state of matter has very low density. This state of matter have very low density. And lastly, the example was, when was the first BEC observed? BEC observed was on cooling rubidium. Cooling rubidium. And the other example could be cold liquid helium. Clear, everyone? Any doubts? Only this much you need to know about this state of matter, that it happens at very low temperature, who discovered it, what is the density, what is the temperature, I have told already, and one or two examples which I have already written. Nobody is going to ask anything extra apart from this. Yes, dear.
Ma'am, cold liquid helium is a gas.
Cold liquid helium is a liquid. How can it be a gas? Fine. It is in the,
So this is,
but it is so cold that it starts to behave as a one unit, and it is very, 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 very cold. Like you will not be able to touch it also. It is so cold.
okay.
Fine. Clear, everyone? Any doubts still here?
No, no.
Okay, children.
Ma'am, can you once tell how was the BC formed? Like exactly like the way the matter got into one component.
There is no specific way out in class 9th, which we need to know. In class, not even 11th and 12th, in your like if you go ahead and study about the physics, only then you are going to know more about the BEC. Even after class 12, till class 12th also, there is no specific, because there are different kind of calculations when you go in higher classes and study physics. It is not the physics which you study in class 9th and 10th. In 11th and 12th also, the physics is totally different. It is based on some calculations also. So there were certain calculations which were done by Satyendranath Bose, which according to that calculation, the Einstein discovered the state of matter. Fine.
Okay.
Nobody to ask about the Bose-Einstein condensate formation, but you will be asked about plasma's formation or what plasma consists of.
Okay, ma'am.
Dear children, only this much you need to know about these two states of matter, nothing more about these, anything else about these two states of matter. Now let us come to the next very interesting topic of the chapter, which is the different scales of temperature. Means, what is temperature? First of all, it is the degree of hotness or coldness. Means even if a substance is hot or cold, we judge it how cold or how hot it is by checking the temperature of that particular substance, right? Then you are aware that which instrument we use to measure the temperature? Thermometer. Already I have also written in this PDF. So thermometer is used, and also why in thermometer mercury is used, because it does not stick on the glass and it helps to measure the temperature. Nowadays the clinical, instead of clinical thermometer we have digital thermometers, but initially in the initial days when you must be kids also, at that time also we had clinical thermometers only, which had mercury inside it. Fine. One second. So there are three scales which we use to measure the temperature. The first is the Celsius scale, we represented by degree Celsius. Then is the Kelvin scale, we represented by K. And last is the Fahrenheit scale, we represented by degree F. Clear, everyone? Now, how are they all interrelated to each other? For example, you are given some temperature in Celsius. How will you convert into Kelvin? If you're given in Kelvin, how will you convert into Celsius? If you're given in Celsius, how will you convert into Fahrenheit? And if you're given in Fahrenheit, how will you convert into Celsius? Fine, these are the main two observations, the conversions which we will be practicing. So first is the relation of Kelvin scale and the Celsius scale. So the Kelvin scale is equals to degree Celsius plus 273 approximately we take, children. Here it is written 273.15. This is the exact value, but we can take 273 in a rough, like a round off figure, we will take 273. Then there is the relationship between the Kelvin and the Fahrenheit scale, which is the Fahrenheit is equals to 9/5 Celsius, degree Fahrenheit is equals to 9/5 degree Celsius plus 32. Clear? So if we know the value of Celsius, we can find out for Fahrenheit. If we know the value for Fahrenheit, we can find for Celsius. And if we know for Celsius, we can find for Kelvin. If we know for Kelvin, we can find for Celsius. Any doubts? So write these two formulas because we will be practicing a few numericals related to these two formulas. Everyone should write these two formulas in their notebook. Written, children? Jitendra, written?
Yes, ma'am.
Okay. Sampath, Yukta, written? And Rohit, Aksha, written? And Harshit?
Yes, ma'am.
Ma'am, written.
Okay, Harshit, hurry up bit, then I can show the question. Okay, let's do one thing. We will practice the question in a normal page. Can I remove this slide?
Yes, ma'am.
Yes, ma'am.
Okay. So the first question for you all is convert 530 Kelvin to degree Celsius. I will give 6 questions for 6 children. So nobody should speak the answer so that everyone gets the chance to tell the answer. Oh, sorry. Okay, then next one is this is A, then second 300 Kelvin to degree Celsius. Then next is 25 degrees Celsius to Kelvin. Next is 373 degrees Celsius to Kelvin. Then next is Then next part is to convert. I'll just see a question for Fahrenheit. 40 degrees, fine. So 40 degrees Celsius to Fahrenheit. And lastly, 160 degrees Celsius to degree Fahrenheit.
Ma'am, once can you show B and C questions?
Hmm?
Ma'am, B and C questions can you show?
Yes. I think all the 5 or 6 questions are already visible now. Everyone will
Yes, ma'am.
solve all the 6 questions. I'll give you 1 or 2 minutes so that we can discuss the answer before we end our class. Please hurry up. Can I start the discussion? Akshara, first question, the answer would be?
Ma'am, can you hear me?
Yes, now I can hear you.
Ma'am, can you hear me?
Yes, I can hear you.
Okay. So the answer is 256.85 degrees Celsius.
So it will be, I'll also have to check using a calculator. Exact value I cannot say. So 530 minus 273.15. Answer would be 256.85 degrees Celsius. Next, Sampath, you tell me the answer for the next one.
Ma'am, for the next one, it is 26.85 degrees Celsius.
Correct. Then Rohit, the next one.
Ma'am, I didn't get this one, so I'm still solving it. I've done the others. I just didn't get this one.
Which one you haven't you have done? You've done the D part.
Yes, ma'am.
Tell me the answer for D part.
Answer is wrong, I think. I'm not getting that the conversion part properly.
See, 373 degrees Celsius, we have to subtract. I told you all that on an average, we can take 273. So when we have to convert degrees Celsius to Kelvin, we have to subtract this. So our answer is 100 degrees, 100 Kelvins.
Yes, ma'am.
Simple.
Ma'am,
Clear?
I was confused in the formula, so I took it to the other side, that's why.
Yes. No. Just wait. We will have to add in case of, just wait. In case we have to convert degree Celsius to Kelvin. Yes, so we have to add. So 373 plus 273. So it will be 646 Kelvins. Fine. So what about 25 degrees Celsius? Harshit, what will be the answer?
Ma'am, yeah, ma'am, 1 second.
Yukta, have you done the C part?
Ma'am, 298.15 degrees Kelvin.
298.15 Kelvin. Anyone has done E and F part?
Ma'am, I did.
Answer for the
Also,
E.
yeah. No, ma'am, I didn't do it.
Okay, so I'll just solve it for you because
Ma'am, I have done for you.
also tell me the answer then.
Ma'am, I am getting 108 degrees Fahrenheit.
So 8 into 7 is 72 plus 32. It is this the answer you've got?
Yeah, ma'am.
That's correct then. So we will put the value of degree Celsius in here and we will get the answer. Similarly, 9 by 5 multiplied by 160 plus 32. So this will be 3, 2. 32 multiplied by 9 is 18, 1, 27, 28 plus 32. So the answer will be 10, 11, 12, 1, 3, 320 degree Fahrenheit. Fine, children? I hope you were able to understand. I will share the PDF.
Yes,
In
ma'am.
that, some more questions are there, so you all can practice those questions. And I'll see you all in the next class. Have a good day, everyone. Bye, children.
Bye, ma'am. Thank you, ma'am.
Mhm.